believe you are.
Yeah.
Crazies. You guys are nuts.
Okay, guys. Can I have your guys' attention in 3, 2, and 1. So you guys should all have your journals out. By journal, I mean your composition notebook, just like just does. This is everyone looks like we have it out. Perfect. And now I want you guys to open up to that page that we left off on for Bill Nye's video. So everyone should be opening up to the page we left off on Friday. This next page right here, I'm going to show you what we're going to write. I'm going to write it on the whiteboard. So I should see everyone on this page. Thank you, Liliana, for opening up to the page that we left off on our Bill Nye video. So you're going to flip one more time. Okay. To the right one. Where? Yes, sir. That back page should be good. Okay. So now on this page, I just want you guys to write. Dang. Being quiet. I want you guys to put a small number 2 on the top right-hand side. You guys know, if you're looking at me, this is your left, and this is your right. It's on your right-hand side. Well, if you're looking at me, right? You guys should know your left from your right, I hope.
I don't know my left.
And then in that big space, I'm gonna wait, because I hear some people talking. Thank you, Robert's table. At that top space, I'll wait. I know you're trying to help, you're totally fine, I just want you to hear me. I want you guys to write motion and force. I'm gonna come around and write that on your table so you guys can see. I want you guys to write on this top part right here. Motion. Thank you guys for being quietly. Motion and force. So I'm gonna write it here. Motion. And it doesn't fit, but it can fit it all in the top space, force, and then a 2 at the right hand side. So right here, yes. Can you see on there? So the top, really, I've already got it. Right, motion and force.
How do the bear look like?
In a second, that's not at this moment. So the top right here, you're right. Motion. And there's a little 2 at that top. It's okay. Oh, thank you. This is small page. Perfect. And I also want you guys to write, no, it's an and sign, and symbol. And symbol. Today I also want you guys to write on the left that it is 10, 21, 24, so October 21st.
You never wrote on our list.
I'm sorry. Yes. Pretty good, right? Yes, at that top space, that's an R. And then, that's an and symbol. You've never seen an and symbol? Well, you can just write the word and. You wrote a picture. There you go. Yes. Okay,
Want me to?
again, can I have your guys' attention in 3?
Don't make me fool.
Justin, Savannah, in 2.
You can play again.
I'm gonna wait for all eyes on me as well.
You did good work.
Anyone who wants to continue talking, please take a step outside. Because I don't really love how people walked in today, if I'm being honest. And 1. Alright, so the reason why I'm also saying that is because I did explain this. These are very simple instructions, but I notice that when I walk around, people talk when I'm talking and then you miss what we're doing. So make sure that we pause our conversations when I'm explaining things so we can get started. We should already be started by now, okay? So, what I want you guys to do today is what? Any guesses? Write what?
No.
There you go, miss. Perfect. We're taking notes. So that is also an expectation, guys. I want to remind you that any clay or anything that shouldn't be out right now should kindly be put away in your backpack. And also that notes are worth 20% of your grade. This is a science class, so we're gonna have to take notes. Andrea, Miss, can you stand out your document, please? Thank you. And I will let you guys know, there are a few slides here, but I want you guys to write at least 5 things that you learned. How many things do I want you guys to write down? 5 things that you learned. How many of this? After the notes, I'll get back to you. Here. So, we're learning about motion and force. I'll just wait for 1. Are you good, 1? Yes, miss.
Oh.
Look at chewing gum again, miss.
Oh, it was not.
I never spit it out.
I did.
We'll spit it out again, miss. Guys, I will remind you, I have to remind you about the rules and periods and all of that. So please do not chew gum or eat it here. And then you can charge it against this. But now can I please get started? I know we have some new kids in here, which I'm so happy about. But usually,
Okay, she didn't say kids.
I did say kids, I meant 1. But usually we get started by now. So I know that we're getting along. But Justin, I'm not gonna ask you again, because you're the one that keeps saying over and over. Yeah, I like your hair today.
Period.
All right. I'll count down again. We're 5 and 3. And there, that's easy. 2 and 1. All right, I know it's Monday, but we gotta get going. Who wants to read this first slide for me? Yeah, let's start with this top part right here. Okay, go ahead.
Oh, four.
Force.
Just Livea. Go ahead. Force. And it's the interaction between
Interaction between
2 objects
objects that
causes
causes a
change,
change in the movement,
motion
motion
of
the
objects.
objects.
Movement's fairly close, right? Well, what's force in your own words?
Just like a paper.
That could be an example. What's force, guys? We were learning it all one.
Star Wars.
So, okay, we don't force one of you. That's funny. But really, what do you guys think of when you think of force?
Force is technically like something such as something down. It could be like bowling pins, like you get ball rolling. And things fall, hits the pin, and things fall over. That's opposed to.
I'm sorry, I can only hear Livia and Juan. Juan, are you not having a good day today?
What's that?
I understand. Do you want to take a break outside, Juan? Okay. I see that you're trying. I'll make sure you're sitting right there. Lunch. Do you want to join him, Ms. Juan? Alright, thank you for that reading, Michaela. Well, example, I should say. And Livia for the reading. So, what impact can forces have on objects? It can make things move.
It can
It
make,
can make things speed up, slow down, stop. It causes it to change direction.
oh, and it, look, you can tell by the time.
Okay.
The way the time moves.
Well, maybe on the analog clock behind us, you can see the movement of the second hand is constantly moving. That's in a sense talking about motion or movement,
Yeah.
right? Sure. And it causes things to change shape. In what way does the mass of an object impact force? We listened and watched a video on this last week. Does anyone know what mass is?
It's like the gravitational pull or so.
Okay, so mass takes up space, right? Mass, matter, these things take up space, they're all around us, right? So this is gonna have to do a lot with what we're talking about when it comes to Newton's laws of motion, when we're talking about objects, thinking about the density, how much an object takes up space, how much it fills up space, right? But force has everything to do with objects moving, okay? So we talked about different kinds of things moving. Michaela brought up some great examples. What are other examples of things moving? Like objects, a car crash. What else did we talk about? Good.
I want to say top five.
Magnet.
That is a force. Magnets, that's a great one.
Like,
Huh?
Like a
Humans moving, I like it. Sure, it's basically, yeah, electronics, it's basically the relationship of two things, at least two objects moving, right guys? So, who can help me read this?
me.
How about you go ahead, hon?
Who? It was Isaac Newton.
Mm-hmm. A renowned physicist?
Yeah.
Do you want me to take over or do you want to
Yeah,
try to
you
read
can
this?
take over.
Okay, yes, who was Isaac Newton? He's a renowned physicist and mathematician from England who discovered in 1687 the correlation between force and motion. Today, his 3 laws of motion are instrumental in describing the movement of any object in the universe. 1687?
Wow.
That's some centuries ago. And we still use his laws of motion today, right? We learned about the 3 main ones, and he basically went into a whole discovery
Wait, did
as a physicist and mathematician explaining what the relationship between force and motion is. Yes, he did pass away because this was like 400 years ago.
Oh.
Yep. Let's have Andres. Can you read this slide for me? Boys, do I have to ask again? Wait to make no sounds and be completely silent for Andres to read. Go ahead. Go ahead, Andres.
Laws of motion
Good.
state an object at rest will stay at rest unless acted on by an unbalanced force. An object in motion will stay in
Motion.
motion at the same speed and the same direction unless
Acted on
acted on
by an
by an unbalanced force.
great reading. Love that. Guys, have you ever played with one of these?
Yeah.
Yeah.
Like, what does that remind you of?
Well, it reminds me of this little cars that I used to have when a car standing in line and one of the cars hits the other car and the car moves again.
Oh, okay.
Those like plastic cars that have the rainbow tracks.
Oh, I see that.
So, yeah.
That's the same thing, right? How
No,
about you?
actually, no, these were metal cars, like, it was like, you know how that little magnet thing is? It's just like that, but it's just the cars, metal cars.
Oh, okay, that's pretty cool. And then, have you guys played with those little, I always think, you know what I think of? I think of when you go to like a doctor's office, or they have like a little play area for
Oh,
kids.
yeah.
And it kind of looks like
Those
those.
little beaches you go around. and-
Yeah,
okay.
right? Like you can have like a little, I don't know what you call it. But that's exactly what that looks like.
Little baby toy.
Baby toys for sure. Okay. So let me have someone from this chatty group back here. Who should I call on?
Justin.
I think I should call on Justin. He's the star of the show today. Can you help me read this, Justin? If you can't, I can help you read. All right, and I know it's a little small. So, Justin, what does this say? I'll wait. It's Newton's second law of motion. Okay, so it states you can just repeat after me. Let's just read some of it, not all of it, yes?
No.
Just 5 words, and then I'll leave you alone. You don't need to say that. Okay, ready? States acceleration.
Let's read it.
Okay, fine, of an object.
No.
Then
I
can we
don't
write
know.
it
Can I
off?
just say it for
They don't
him?
dress for
It's
it.
easy.
Okay, well, Justin, let me be fair. I understand, I can appreciate if you don't want to read, I'll respect that, but I want you to respect that we need to not be talking right now. Okay, sir? That's fine. Robert, go ahead.
States the acceleration of an object by a force is inversely proportional to the mass of the object and directly proportional to the force mass acceleration.
Good reading. So what I want you guys to write down in your notebook, I'm gonna give you hints here and there. You should have had something written down for Newton's first law of motion. So if you haven't, I'll go back and I just want you guys to write object at rest.
Object at rest.
There's obviously more that goes into that first law, but that's one of the key things. So it says it right here, object at rest. So Guadalupe, did you write this down, miss?
What's the next?
Object at rest. For the first law, it's in huge letters. You can just write first law, object at rest. I'll give you guys a few more seconds. Yes, miss? If you wrote more, that's totally fine. Make sure that's on your paper. It's okay, just write that down now. First law, object at rest. I'm gonna challenge you guys to try to write more notes on your own. Don't be so worried about writing the wrong thing. I wanna see effort. Okay? There will be times when you guys can talk to your shoulder partner, your group, to get ideas, compare notes. But I want you to try to write things on your own, right, Justin?
Yeah.
Okay, I'm gonna switch slides now. In 3,
1.
2, 1. And now, for the second law, I just want you to skip down to number 2 now. That was number 1. Please label the number. For the second one, I want you to write what's in bold here. So this is force equals mass, and that's actually a time symbol for my math people. You should have learned that with me last year. Mass times acceleration. I know it's a little hard to see, so if you need to come up, excuse me, if you can't read it, I'll write it on your table. Yes, sir. What are we done with
Do
this?
you write?
Sorry?
Yeah.
I think Robert just read that one. You can help me read the next one?
Miss, I
Do
don't care.
we just
Miss, that one's not working? You can leave that one up. Just leave it on my desk and I'll plug it into something in a second.
Okay.
so what do we write?
For the second one, it says in bold, force equals to mass times acceleration. Mass times acceleration. What does that even mean? What does it mean to accelerate?
To go
Do you guys think
faster.
of, thank you, right? It needs to go faster, and what do we say mass is?
Big.
Okay, you can think of like volume, it takes up space, right? So when you think of mass, think of any object. Usually you can touch it with one of your five senses, you can hear it, or you can see it, touch, smell, maybe not taste. It depends on what object. It's one of those things, it's an object, and it's something that goes fast. That's why you see that hand, and you see the movement of the object. What does it look like his hand is doing to this block?
Pushing it,
Pushing it, and what else?
punching it,
Maybe punching
pushing
it,
it back, pushing it.
and pulling it.
Taking it.
Pushing it back or pulling it. Maybe not kicking it, yes, miss. Looks good. Alright, good, and then, how many more laws does Newton have? He has three, I know you're listening. So we've learned about this one,
We have that one.
we have that one.
It's just broken.
Yeah, because of Wendy. Shout out to Wendy from last year.
She's a girl who,
Most about all of them.
Yeah, so what do you guys notice is happening between these kettlebells? Yes,
All of them are going instead of just like two of them.
okay, but what do you notice right now? Which ones are moving faster?
The last one?
The ones on each end, right? Or how about, let me stop that, how about if I do that?
Oh, the.
Right, they kind of follow in this chain reaction, right? So, we talked about this, there's an equal but opposite reaction. So for this third one, number 3, I want you to write third law, equal but opposite reaction.
Wait, right, what?
For the number 3, you're gonna write third law, and then you're gonna write equal but opposite reaction. If that's again hard for you to see, let me know and I'll write it on your desk.
Yeah, that's the one.
Okay, let me grab my marker
It's for sure.
and I'm gonna write it. Yes, miss.
It wasn't Wendy who broke that.
Was it you, miss?
Yeah, because it was one day when I got a tangle. I got a tangle one day and I was trying to fix it. And me and Wendy, we started
Oh
fixing it.
my gosh, well, at least it's a
So
fall.
now you want to.
Can you get the turkeys?
Yeah, all these months.
You said.
Wow. I would have never known that.
I thought that was real thick.
So instead of equal, you can write equal sign. So equal, but opposite. Moving down, right? And then Let's good on, just make sure you label number 3. Equal and positive. Yes. So I want you to write equal, the opposite reaction.
I don't know why all of this.
Yes, miss. I'm sorry, guys, when I was talking, we were both talking over. Yes, I want you to write that on your paper for number 3. Right there, huh? Equal but opposite reaction. It's right there at the top, but I also wrote it right there for you because I know it's a little hard to see. Can you read that, miss?
Oh, yeah.
So you're just going to equal, no, opposite reaction. What I wrote in green. Can you guys not see that? Okay. Justin, what did I say? Equal, no. Not till after the notes. That's why I asked you. And then you look a little distracted, huh? So it's like, I mean, he's focused though on the lesson, are you? Are you talking to him?
Yes.
I'm focused.
So maybe I'll have to do a seating chart next week. Let's keep it sweet. I'll grab it from you later. Thank you. And then are you doing good?
Yeah, I'm doing good.
Okay, Juan, I know you're just joining us. Don't worry, I'll catch you up to speed. Yes, miss. All right, so,
Miss, can you, we do, as well as writing ready made, because, Dustin,
Let's
raised it.
okay, guys. Let's go, I'll help you out in a second.
It's third law.
Who's that? Okay, guys, thank you guys for being quiet in 3. Quiet in 2. And 1. Justin, how can you step outside, please? Cut off just. So, we just named different examples of each. We already talked about the first, second, and third law. But for this last one, I know we used the kettlebell example. What's another example of this third law? You guys did a whole comic strip on it. What did you guys draw about? I know you didn't get to do it because you joined our class right when we finished. But the last one, guys, what describes an equal but opposite reaction? What happened when we saw the car driving down the hill, right? It was accelerating. And imagine it hitting a wall, and crashing a wall. What do you guys think?
The person's gonna fly out and.
Okay, hopefully not that. Okay, he thought about it from a different angle. He was like thinking about the person inside of the car. That's
You
actually
want me to think about the car?
not necessarily, because in this
Technically,
law,
people sometimes don't wear seatbelts because they're like drunk or so.
okay, our imagination's going a little wild. I mean, you're not wrong.
And
You're not wrong. You're not wrong. What I'm saying is, we're talking about anything, any object that's involved in this scenario, and he's not wrong. Let's say a person was driving their car and they hit it in a wall. Typically, that force would cause, if it was really bad, a person could fly out the window based on the impact.
It's because.
Right.
and some people do have
Yeah, I mean, there's other little factors. Maybe they weren't wearing your seatbelt.
Because like the seatbelt, when somebody stops the brakes too hard, your seatbelt automatically straps you, but it makes it like the point when you can't move all the way.
That's true. There is some resistance there if you have your seatbelt on, but it depends on the level of impact. If a car was going maybe 90 miles an hour, and then it hit another car, what do you guys expect to happen to the other car?
Big crash.
A big crash, but
It's gonna hit the other car, then the other car's.
yeah, it could cause a chain reaction, yes. What do you say? The driver could potentially fly out the window, right? There are all these different factors.
That's true.
Alright, let me bring your attention back in 3. Bring your attention back in 2. And 1. So you guys are thinking, which I like that, like you're imagining the situation in a real life case. Another thing that's not on here is, right, we talked about, unless there's another force that intercepts the situation, right? Unless an unexpected force comes into play, right? That would be like a third object, right? For example, over here, you see this person pushing and pulling that cinder block. They're gonna keep at that all day. Well, let's say I come in and I kick that cinder block out of there. What's gonna happen then, right?
Boomerang, that's like a boomerang.
Yeah, it's gonna go a whole other direction. That's an unexpected
And
force.
it's gonna-
Say that again,
It's
Miss?
like a teaching us.
Sure. Okay. So I'm gonna read this last one. And for all my science friends in here, you are seeing some math on the screen because science and math go hand in hand. So it says the measure of an object's resistance to changes in its state of motion due to the application of a force. So momentum is mass in motion. Momentum is mass times velocity. P equals m times v. I don't expect you to write all this down, but I am asking you to write at least this first one down. Momentum is mass in motion. So on your page, I should see number 4. If you took extra notes, that's fine. Write this somewhere on your paper. Momentum equals mass in motion. Momentum equals mass in motion. Honestly, you can read that just fine. Yes, you can. Because you wrote other things just. Momentum equals mass in motion. I want to ask for your help to ask your neighbor if you can't see, just because we have to consider time. Yes, miss? Question? Write down this first one, miss. Momentum equals mass in motion. Thank you, Guadalupe's group. Thank you, Michaela's group, Juan Jesse's group, Esmeralda's group, okay? Emiliano